Oh, hi. My name's Irrelevant. And as you can see, summer is finally upon us. And even though we might be living in a time of crisis, the grass, she still grows. And the bushes, they still need to be trimmed. And sometimes to trim those bushes, we need the right tools for the job. Some of those tools, they can be rather expensive, and you might find yourself wanting to improvise. For that reason, I modified and souped up the snot out of this old Black & Decker string trimmer. As the story goes, this is an old Black & Decker Go Pack string trimmer. And I probably should have cleaned it up a little bit better before I brought it in here, but you know what? This end bit just kind of comes off here. Just kind of okay. That's the dirtiest part. We're gonna have to give it a bit of a vacuum there before we start working on it, especially if we want to test on it, right? So this thing is from the mid, possibly even early 90s. My father bought it to work on grandmother's yard. This is actually one of the first cordless string trimmers on the market, but it wasn't fully cordless. You see, it actually had a belt pack with this big sealed lead acid 12-volt battery in it, only 7 amp hours. And as is with tools of the time, you know, the battery didn't last very long. Maybe didn't get you through the job you needed to get done. It was hard on the battery. The battery freaking took forever to charge after, and it only lasted a couple seasons. This, of course, is what went down with this, and it sat for almost 20 years until I had my way with it. I had this bright idea where I took an old ammo crate, a broom handle, and some scrap, what were they again? Wagon wheels, and I rigged up this cart. I threw an old car battery in there, made a custom cable for it, and I would tote that cart around the yard doing the jobs that had to get done with this thing. That was until recently when I got a proper gas-powered string trimmer, so then it could do the more heavy-duty jobs. However, this is a bit of a beast of a machine. Like much else I got it used, but it works great. It's a nice, what is it, a Husqvarna? Yeah, I think it's a Husqvarna FS85 or something like that. It's really good for chopping down the big weeds when they get wily there in midsummer. But for doing a more delicate surgical work, like just trimming up around the sheds and stuff, it's like trying to kill a fly with a shotgun. You know, it's fun to do, but you're gonna make a mess. So for that more finer surgical work, this thing is still relevant to me. Now, as you can see there, I've already done a bit of an upgrade to it. It's pretty simple, you see. I went ahead and installed a custom battery mount. Now, this doesn't work with the standard cells, but I have a 6.0 high output Milwaukee cell, and it works with that pupper. Yeah, it's a bit tricky here. That's a little bit more chooch factor than it originally had. And as great as it works, it does have one significant major flaw that needs to be dealt with, and that's the switch gets really hot, like really hot, like it just can't even. So we have to do something about that. At the very least, we're going to be installing one of these little guys right here. One of these little guys, an IFR 1404. That's what they call a MOSFET. And MOSFETs are amazing little devices because if wired correctly, they make for a very effective high current solid state relay. This guy right here is rated for something stupid like 40 volts and 200 amps. I find it hard that you can push 200 amps through this little pupper, but apparently you can. So at the very least, at the end of tonight, I'm gonna have this guy installed into here so that I can have proper control. The other option that I'm considering is I have this chowdered out Milwaukee 1606, is it? No, 2606 drill. Now, a buddy gave this to me. It was being problematic. The chuck doesn't grip anymore. It seems like it's not gonna work anymore. I've already scrapped parts out of it. I took the brushes out of it to fix another drill. It otherwise worked great, other than the chuck just won't lock up anymore. It seems like it wants to, but you'd be drilling, and then all of a sudden the bit would just come out into the project. It's no fucking good. Now, however, the electronics on it are still in good condition. And before you ask, I tried to replace the chuck. I even have a replacement over there. It seized on there. I tried heat. I tried freaking penetrating oil. I freaking put an impact gun on this thing. It was not breaking loose. So I had no money in it, and I'm scrapping it for parts. So it's no loss. First thing we're gonna have to do, now that I'm done with my anecdote, is maybe investigate what's going on inside of this thing. So we gotta get her open. Ah, perfect. It's always great when you have the right bit that you need for the job. Where's oh yeah. I keep these little numbered solo cups here too. So I've already been inside of this thing. It's pretty straightforward. There's the switch, which is probably half melted by now. That's where all the heat's being generated. Yeah, look at the heat on this. Look at that. It's like toasted, bud. That is NFG. Now we're still gonna need this switch to be our trigger because it interfaces with this contraption. Hey, come on, buddy. Cooperate, play along. This contraption here goes in. No, it goes right there. There we. Oh shit. Well, I hope that wasn't important. We might have created oh, that was supposed to go in there. That's our recoil. Damn it, we're gonna have no more recoil. We're gonna be completely dependent on the spring in the switch itself. We might have to figure something else out. Well, that's what's going on in here. And I soldered these into place, so those aren't going anywhere anytime soon. Oh, I used the good tape too, eh? Wow. Yeah, I'm gonna have to unsolder all this. In the meantime, we should investigate this next. See, the idea is, if I could take the circuitry out of this guy, I might be able to set it up in such a way that I would have both regulation, because that thing's designed for 12 volts. If I just go ahead and run it at 18 for the rest of its life, I don't know how long a life that's gonna be. It seems to want to work fine at 18, but you know, that's how stuff is. You overclock it and it's just not gonna last as long. I don't even know if I should bother putting this thing back together when I'm done. Just been darn scrapping it damn parts here. The other drill I repaired, you know, it's got a good gearbox, but the motor, seen other days. Who knows how many sets of brushes it had in it, because the actual, I believe it's called the commutator drum, is like, it's worn divots into it. That machine has lived. I need a special screwdriver to get into this hole. There we go. All the tools is what I have. put this in a little baggie and label it spare Milwaukee screws. I don't know that you can actually take this apart until you pull the complete gearbox off. This is a drill that's, it's been... I wonder if this... Oh, even the motor assembly has cracks on it. Look at that. Look at those cracks. Yeah, this drill, how's that go back together now? Doesn't matter. This is not what we're here to work on today. Stop getting distracted. What we're looking for is the electrical. There it is. So the question is, can we take this circuit out and install it into that guy? Now, we wouldn't necessarily be installing it the same way it is in here. Like, we unlikely will be repurposing this trigger, even though this trigger is kind of important. The idea behind this is that I want a regulator circuit. I want a regulator circuit so I can adjust the speed of that. And it's a pretty simple task. I could probably install this regulator circuit into the head right there. BAT plus, SW out. So we have a good hang of like what's in and out. There's this black wire here. I'm not really sure what that does. See, these three here are straightforward to me. Somehow you adjust the speed on this drill as you go in and out. Somehow. Right? And that somehow is by these three wires connecting to a potentiometer in here. So once we determine the value of this potentiometer, we can sub it out. We can do one of two things. I can either put another kind of potentiometer in there, just a plain old knob, or I could hardwire some resistors on here to fix the output. Oh, there's battery sensors on this too. That's something we didn't bank on. One thing that happens with this Go Pack already is that the battery gets confused. In fact, I bet if I press the button right now, oh no, it still reads. What happens is after I've been using this for a while, the battery gets confused. It doesn't actually know it's connected to a tool. So when I go to press the button, it just blinks me like an error code. And then if I attach it to another Milwaukee device, it won't actually work anymore. I have to put it on the charger, and then it kind of resets the circuit. It tests it, and then it does stuff, and then it starts working again. This has a battery sensor circuit on it. There is a possibility that unless I hook up all four of these battery prongs to the battery, which is not possible with this little dilly-dally we have, this circuit might not engage. We kind of have to set up a simulation. All right, well, I'm going to use yellow as the positive. And now the positive has to go to this side here. This melted ass wire. Oh, great. Look at you. You're winning. Ugh, that's not going to make a good connection. It's going to melt to hell if I try to pump current through that. Let's put the probe in there. That'll get a bit more current in there. Good enough for testing purposes. Wait, that's the negative. All right, we need to get our story straight here. And motor positive there. Then we have motor negative here. Motor positive here. Now, the question is, we connect this to El Baterio, and we go, oh boy, oh boy. You can't see it, but you can hear it. Oh boy, these wires are toasty. She's regulated, bud. She's regulated. Oh, she's got a little, oh, the blinker went out. So, well, that's a semi-success. Now the question is, all we're gonna do is we're gonna unplug this connector here. That's gonna disconnect the battery sensor. Now, let's see if this circuit's gonna work in a more dumb state of mind. Nope. Nope. You know why? It looks like one of these prongs is the actual power for the circuit itself, for the intelligence. Now, just to make sure we didn't fry this thing, let's plug that back in. Okay, now she's back to normal and flying away from us. So, we gotta get it to work without that blue and black wire. Well, the thing to try is to unpin those two prongs. Let's make sure we label stuff here. This one's is the blue. And you know what, that's good enough. I'll be able to tell which one's black. You know, it would be ultimately better to have this logic in there. Because with this logic integrated, the battery would always work properly. And in fact, I could probably use the lower end batteries because this circuit's probably also regulating current to the motor. All right, blue and black wire are now disconnected. So we're going to plug this back in and see. Nope. She's a no-go. So this circuit board, the computators on it, will not allow this thing to operate unless it has full communication with the battery. So, that kind of writes off my ability to use this for the purposes in which I am discussing. Short of maybe another little master plan. Yeah. All right, now let's put this all back together. Let's see now if it still works. It does still work, yes. T-phone home. What are the chances that we can make this thing the battery holder, if you will? It's pretty gaping in there, man. That's like not gonna, unless if I start chopping up this handle. Like maybe if I cut the handle here, it'll well, let's kind of half put the, this is difficult with all these guts hanging out now. Kind of need to mock up putting this handle back together. I think it's possible that regulation might be a tall order. How do these pieces fit? That would require gluing. I hate gluing. What are the chances this switch will even fit in here some way, somehow? Be nice to have the regulation, but it also is a speed control. Like, there's some redundancies going on here. Or not the speed control, the direction control. Reversing a string trimmer. What purpose would that serve? Oh, it's one of those defond switches. I see, said the T, fizzing up the tree. It's all coming back to me now. Man, I know I can do it. But how much work do I want to put into this thing just for a little bit of regulation? See, if I can use the speed control, and that's nice. But if I can't use the speed control, then what is purpose? Imagine being able to delicately just nip at those weeds. Zip, zip, zip. Zip, 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 zip. Zip, 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 zip. Some shims? Can we shim this? Eliminate that handle altogether and just shim it? Because you got bolts that go right through, but not really bolts. That's the thing, we would need bolts that go right through. So we'd have to put holes in the casing of this, and then it would be very sloppy. What do we have in the hardware departments? No, those aren't quite long enough, sir. This one's long enough, sir. But I only have one of these, sir. Oh, there's a nice bolt, sir. Oh, it's just a little bit too short, sir. Oi. Oi, I got a lot of these bolts, sir. Yes, sir. How did they go through there, sir? Not quite, sir. Not quite, sir. Oh, boy. Bolt blocked. What I need are a bunch of longies like this, but... Oh, boy. I might have something. I gotta steal it from somewhere else, but... Oh, these are for mounting my vise to the workbench. So if I use these, I'll have what I need today, and then I can just go ahead and get something else later. I need to undo these guys right here, for they are getting in my way. Metric or imperial, you want to take a guess? Oh. Why did I try to think that they were going to be 11 mil? Everybody knows it's 10 mil. Everybody knows it's 10 mil, bud. Okay, loosen, like, get the... Oh boy. I mounted this on good. I didn't want that to come off, did I? It's difficult working with this whole business at the other end just hanging off. I can remove this thing and fix it in one position. Okay, we have a problem. There's a reinforcing part right there. If I chop a hole in the middle of that, in the middle of that. Okay, so scoring. Scoring is not always easy in neither sports nor romance. And in this particular scenario, it is ever so more difficult trying to find just the right spot. I would like that to bottom out, but then it goes through these grills right here. We're just gonna find out what these polymers are made of, bud. Okay, we just need to center point this. Somewhere there, and somewhere there. So there, and there. Now that is the access this way. You know, what are the chances that if we tighten this up against the bottom, it will be less of a nuisance? I need to get that off there. Let's just get savage here. Let's get that out of there. Let's get this out of here. Let's get this business out of the way. Let's simulate this clammy experience. Let's tuck these wires out of the way. Then if we move it down like that, we don't even necessarily need as long of a situation. I'm just getting silly now. I don't see much advantage to that. Unless, like, we bolted it to the bottom or the top. Okay, well, we need a drill bit that's as big as this, which is 9.47 millimeters. Bit library. 8.75. 9.47. Really? Is it going to be that easy? 9.43, 9.46. Dates and names, they change as you progress through your story. Pilot hole? Yeah, maybe we need the punch here. Careful of the electrical wires. Oi! That's going to be difficult to drill right there. We almost need to try again. We're going to drill this hole. And then we're going to, going around the back, rescore it, drill the other hole. But first we need drill. We're going to use a Milwaukee to ruin a Milwaukee. Today, can a Milwaukee drill a hole in another Milwaukee? The results might shock you. You know what? I have a more appropriate bit for this, one of those cone bits. I'm surprised this PH6 glass fiber reinforced 30 polymer, it's taken a little bit of abuse. Or maybe my bit's just dull, but I can tell I half-ass sharpened this one. Perhaps this is just the wrong bit for the job. Well, hold on here. Hold on here. How big is this again? This is a 3/8. Do we have 3/8 on this? Yes, we do. It's right there. 4 steps in. This is a stepped cone gibbet. Looks like little Papa's shredder used to hunt the turtles. Oh yeah, there we go. All right, a little bit more. Is that 4 steps in yet? Well, we can get the bit through for the most part. Ow! Problem is we don't want to completely chowder this. That's great. We got all these red, pink. It looks red, but when you drill it, it's pink. Okay. Now we're making progress, sir. But now when we have to go in through the outside, need a little bit more light to line up this shot. Again, I wish this wasn't the way. This is going to be so half-arsed, sir. Give me, give me never gets, so would you please hand me the little punch device, sir? So, screw it. I will use a marker. Alright. We have our rough target acquisition. Oh. Okay. That's a little bit more to this one. Engage safety squints. Actually, I should say it's someone else's trademark, isn't it? Oh wow, that hole just doesn't quite look where it needs to be. We'll bolt go through it at least. Eventually. We're gonna have a bit of a cant here. But just because we have a cant doesn't mean we actually can't. Or doesn't mean we can't not can. Just because we have a can doesn't mean we can't not can, sir. Doesn't mean we can't not can. Alright, so we have one side drilled, and so do we have to do that all over again on the other side, or can we find a way to maybe imprint our straight directions right on to the other? Turn off this light so the camera can see proper. We want it to be somewhat straight, right? What if... Get back here! Swine trimmer. I think so. It's right about here, sir. Right about here. Let us witness. Yeah, that looks about right. YOLO! Okay. How's the butt? Ah, I made the hole a bit too big. Great. There goes our tolerances. Then maybe that means we have a little bit of room to move. Alright, now once again, we have to line this all up. We have to mark another point of entry. So if that hole is there, then the next hole will be right about here. No! Wait. Not even close. Right here. Yes. That will do. Come on now. Let's do this. Let's do this, bud. Do I have this in reverse? Why does this take so much effort, sir? How's the bolt fitment? A little bit more. Just give me a little bit more, sir. A little bit more, sir. Okay. Alright. Alright then. We might be making some progress. I want my shorter chair. I have to hunch down too much with the chair. You can see me better now anyway. Alright, sir. Alright, sir. We have some experimentation to do here, sir. Need to vet this procedure, sir. Make sure that this is going to... These plastics aren't going to be terribly useful ever again. Okay, so this looks quite rather sloppy, sir, but if it gets through to the children, then we might have a chance. Oh boy. Right. Huh. Problem is it's all over the place. Those two screw holes are too close together, sir. They're a bit too close together. And now these other two screw holes don't want to line up, sir. This is going to be very force fit, right? Just like that. So let's try to see if we can line these plastics up a bit. Need to get everything slotted into place, right? Now, just a little bit of force fitting, sir. Just a little bit of... So, maybe we're kind of doing one of these. It's a little sloppy, but you know what? I think it's probably gonna work in practice, right? Look at that. Problem is now we just need some spaces, huh? What do we got here? What do we got? So give us our precision measuring tool. It looks like about 8.69 millimeters in those sections. And I don't know how much in other section. We'll get it roughly center. Then maybe some marks. Except they cannot get down there into... Okay, well, that slides over, and then we can possibly do one of these right here. Alright, now let's see if we can get a measurement set. $11 mil. 9 mil and 11 mil. Somehow we need a spacer. Something that will be somewhat rigid. 9 mil and 11 mil, and well, hell, I got something in mind. Where might I find it? This is roughly 3/8 after all. Oh yes, sir. You know what else is 3/8? Computer hose. I don't know what kind of computers you're running, sir, but they must suck if they don't have water hoses in them. Now this stuff is entirely... My first water cooling project used this thick ass hose, which was ultimately too much of a pain in the ass to work with. So many years later, it's just sitting in my bin, unused. I actually did manage to do my first water cooling build with this hose. But then when I had to take it apart for service, it's like, yeah, screw trying to get that back on there, right? So, we should leave the marker closed. And we should acquire our measuring device. Once again, we needed a 9 mil shim, roughly just under, which is around there. We needed 4 of those. Where's the cap for this? The little workbench here is starting to get a bit hectic. Don't worry, sir. I have a hose cutting app right here. Right here. So apparently, this is gonna go here. And then the other one needs an 11 mil. I would like a more precision way to mark this though. 11 mil, sir. 11 mil. 11 mils right there. Got all these little chippies in here. Chips in here. Alright, so we need another 9 mil or 8 point something mil. And then one more 11 mil, sir. One more 11. All right, sir. So 10 mil, 11 mil. No, 9 mil, 11 mil. Get through the whole mill. Hey, that looks pretty straight, bud. I should use a different term. I think it's only a matter of time before it's politically incorrect to refer to things as straight and crooked. Oh, that one's in tolerance, that one's out of tolerance. Oh, great, now we're talking about tolerance. Oh boy, oh boy. All right. So, I need to get the little pieces to line up, so. Oh, yeah, that feels like progress to me. Yeah. I'm getting excited, can you tell? Great, you know what? This isn't gonna quite work the way we want it to. Or is it? Oh, that feels solid. Oh, hell yeah. Bud, this is gonna work. This is totally gonna work. And it even has some shock mount to it, man. We're gonna be like zing, 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 zing. And it's not gonna get confused. It's gonna have a Milwaukee OEM computer chip in there saying, yes, sir, this is a Milwaukee tool. It shall be used with Milwaukee batteries. Haha. All we have to do is ready to go. All we have to do is solder it onto these connections right here. Plug and play, practically plug and play, bud. We're even gonna have an LED in case we want to trim our bush at night. We all know it's the sun, it goes down so early in September, but you still got your bush to trim. Now, your trim has got a light, bud. Problem solved. All right, then. On this already busy bench, we must acquire another tool. And it's great. We're going to be able to save our high amperage MOSFET for another project. This is about as tool song as a conspiracy theory gets. When the pieces just won't fit, you make them fit, and that's why we have to wear our tinfoil hats, right, people? Ugh. All right, so this main power wire, which has been choppy, now is going to have to come. We're probably going to want to slack it a bit so that in case something goes wrong. Now, let us determine real quick which switch position is going to be forward. Where's that little piece we discarded, or should I say set aside? I also get this Milwaukee carriage here for a future project. Battery mount. Get these out of the way, sir. Get these out of the way. Out of the way, sir. Oh, great. Did we haphazard? Oh, no, it's right over there. All right, so that goes in there like that. Forward is the switch pushed this way. So I can assume that will be correct rotation. You know what? Just for the lulz, we're gonna go ahead and put the selector switch in there anyway. So if we do get it wrong, at least we are just a switch flick away from getting it right. And just for the lulz, we'll be able to make this thing go in reverse. You know what the problem is? It's gonna say, I think we got some of this backwards here. Oh no, this piece does look like it goes this way, so gotta cram all these guts back in there. Oh god, no, that's gonna get in the way. That's gonna come up and around here some way, somehow. Some way, somehow, we see the light path here. It almost seems like it'd be easier to put it on this shell first. Just start cutting wires, bud. Just like that. All right, what gauge you figure this is? It's a smaller than that. Close enough. Okay, let's see what we have for switch mounts here, sir. Oh boy. These are going to be a little tricky to solder to. Okay. It's all going up in my face. Oh, I don't have proper ventilation. Tins of wires. Tins the wires. So, we need to take wires. Wires, they tuck down. They come right about here. We need to get ability to hold without get the burn. Let us get the solder point nice and hot. So that we may achieve a good fusion. Oh yeah. If only I could do this to my piece of shit chainsaw. I want more solder on this. I hate white rabbits. I hate white rabbits. I hate white rabbits. Alright, let's get it all nice and molten. Cut up a bit. Give it a second. Now, to get other piece of clamshell into place. By Jove, I think we've got it. The trigger has a spongy feeling, like something's jammed up in there. Okay, we need to do this proper, bud. Since this is going to be the last time we're putting this together, we need to put it back together the way God intended. And by God, I mean Milwaukee engineers, which might be giving them entirely too much credit. Now I'm going to put them in the other way. Right? Like that. So, 9 mil up front, 11 mil up back. Hey, where's this light go? This is the problem. Where does this light go? This light goes in here and down through this. Yeah, see, it all makes sense now that we put it together in the right direction. Yeah, that light is supposed to be coming in from the other side. All right, back down into the channels and pathways. Yes, sir. It all fits together now, sir. Hey, don't drift off on me, you bud. Okay, where's our two little shims? 8 mil, 11 mil. Oi, I forgot to put in the crystals. Yeah. Now we do the force fitting of the components. Or no, sorry. This is what we call interference fitting. Engineering ain't easy, bud. Oh boy, this is just... Looks like herding cats, bud. There, that looks better. Right? Right? Hey, why are you trying to float away? Come on now. Cooperate. There we go. 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 All right, the button feels smooth now. Oof. Oh, and of course the washers don't fit on this side because these holes are a little bit not quite. Just smash it. Just interference fit. Why are you... It's trying to spread apart. Okay, let's nip this in the bud right now. And get some of these screwed down. All right, good stretch, bud. Oh yeah. Now she's tight. That actually feels really good. Like that, like, oh, okay, let's not abuse it too much, right? It's just a part of the puzzle. It's not the full load bearing experience. So now, go like this. Look at that. Just some surgical weed whacking. Nope. This thing's gonna be full ball surgical, man. Oh look, I have reverse too. That's great. Because a string doesn't really care which direction it goes in. So if I want to send the crap that way, or do I want to send the crap that way? Now we have options. Just gently dust. Oh, now I'm making messes, sir. And now here I am, being the typical dude I am, seeing if I can play golf with a little screw on the floor. Oh, you missed that. If only I had cameras everywhere. The point is, and it's decently I can control the speed of it. Oh, full chooch. Now here's the questions, huh? The question was, before, this would only work with the big 6.0 HO because there'd be these power surges. But maybe with some regulation at the soft start, we can use the smaller batteries now. What do you think? Will it work with a high output 3.0, which is equivalent to a regular, you know, big pack? Oh yeah! It'll work with all my M18 battery packs now. Oh boy, okay, I'm getting too carried away. I better quit while I'm ahead before I destroy something, bud. So what do you think? It's not elegant, but it's gonna get the job done. This is great. I'm stoked. This is one of the more successful MacGyver mods I've done in a while. Well, take two old pieces of crap that only half work and make it one good working, not so piece of crap. That's how we do things when you do all the things. Careful around the wire. Oi.
So yeah, that's what the little unit's good for. Just quickly trimming around a tree, whereas the big full-size gas units might actually damage the tree a bit.